Hi class, it's Bill Berry back with another Java 2 video, and this week in week 11 we are looking at hashing and hash sets, hash maps, etc. In the first video we talked about the basics of hashing. What is it that we want? What are some potential ways that we could implement it? And then we actually settled in on how hashing actually works. We talked about a lot of the critical concepts, and we said in this video we wanted to look at a little bit of code. So let us peek at that. We're going to jump down to slide number 14 here. So let's look at some hash sets of primitives. So here I have some sample code. Let us look at it. Okay, so here we go. Let's start at the bottom. Remember that our example here, we are going to use separate chaining rather than probing. So in this case, we need a node class, and we're going to call that a hash entry. It's going to have two pieces. It's going to have the data, which remember is always going to be an integer with hashing. And then we also have another reference. The second thing is in reference to a node of the same type. So it can point to another node. So this is going to be a very simple class. We could, as you probably remember, we could make this static because this doesn't need to have access to anything in the outer class, so we could mark that static. That would be fine. And then we provide two overloaded constructors, one where you just give it the data, where we're going to set the reference to null, and one where you give it the data but also then give it what the next entry is. That's going to make it really easy for us to put things at the front of the list, which is going to be a little bit more efficient than walking down the list and adding it to the bottom when we're doing our separate chaining. All right, so now let's go back to the top and look at what's going on. First, we have a couple of constants. Remember, load factor is an important thing. So we're going to say 75% is what we're going to call it. Could be another number, but that's what we'll say. And then some initial size. Now, I'm not sure you really want to make yours this small, but for our case, we could certainly do it for a test and make sure that we see it growing accordingly, and it should do just that. Next, we're going to have our array. So we're going to make a reference for that, and then we're going to fill that in, of course, in the constructor. And we're going to have a variable for size, which says how many elements are you maintaining in your list, in your set. So in this case, when we get the constructor, of course, we make a new array, the appropriate size, and we set size to 0. Now, if you want to add, what you're going to do is first you're going to run through the hash function, which we'll look at in a minute. You're going to pass the value that was passed in to add. You're going to pass it to the hash function. That tells you what position it's going in. Then at that position, you're going to create a new hash entry using that same value and whatever was in that position before. Now, think about it. That could have been a null because remember, this is now references. So those are either null or maybe there was something there other than null, but whatever it is now, that becomes the thing that this new node is going to point at. So this is a very clever way to insert something at the beginning of the list, and the rest of the list is going to come along for the ride, right? All based on this. So that's pretty cool. And then, of course, we increase size, we increment size because now we have one more value. Now, of course, what we're going to do here is we're going to see if, first of all, if it's already in there. If the add is being given a value that's already there, we don't have to do anything, right? Because sets, by their nature, are going to only store unique values. So we say, look, check and see if it's already there. If it is, forget it. Then, if it's not there, first thing we're going to do is check the load factor, right? So we're going to call the load factor method. We'll look at that below. If it's greater than the load factor or greater than or equal to the load factor we set as a predetermined value, we're going to rehash, and then the rehashed one we would be inserting a new thing in it. So now let's keep going. Let's see. In fact, let's go down there and look at that. Let's go find our hash function. Remember that should look very familiar from the slides. Load factor should look very familiar. We just take the size. We're going to cast that as a double because we don't want to have some zero result here that's going to throw us off. It's a very common error. Take the length of that, get the load factor. Rehashing should make sense, right? You are going to make you're going to point to a new pointer to the old data, and then you're going to have in the element data, which is the thing we're keeping, you're going to make a new array. In this case, we've just multiplied by 2. That's a constant you might want to pull out and put at the top, sure, and the size is going to be 0 for that thing. And then we're going to go through all of the old array, and one by one we are going to map it to the new array, right? So we have to go add it to the new hash array, the hash table, each element that's in the old one. Hopefully that makes sense. Okay, so now let's go back to the top and see if everything makes sense. So we've talked about add. Here, if you want to clear it, you can go through each thing, go through the whole array, and mark everything null. Why? Because these are nodes, remember. So since they're nodes, we want to set them to null, which also allows garbage collection to run. So you can't just set size to 0 because you really do want the garbage collector to do its thing. Now contains should look really simple given what we know. Take in the value, run it through the hash function. Then the only thing is, remember we have separate chaining, so sometimes you've got to set a pointer like you do with a linked list, and sometimes you have to do a while loop and go current equals current.next to keep looking through that list to see if you find it. And eventually either you found it or you didn't and you ran out of room, and you ran into a null, and then you return a false. Is empties easy? You just check and see whether size is 0. Remove, the only difficulty there is sometimes the array points to null and sometimes it points to a node. So our code here looks a little bit longer here than you might expect, but this doesn't use an x equals change x approach, so that's why this is a little longer and you treat the front a little different. But hopefully that makes sense if you pause and look at it. ToString, pretty straightforward. Everything else should make perfect sense. So that's just a quick look at some of the code involved in working with just integers. As you're going to see, it's not going to change a whole lot when we get into working with objects, but it will change a little bit. Now let's see if I have some sample code that actually runs these things so that we can check it out. Alright, so we'll look here at main, and I'm just gonna set this thing here because this is my test code, or my demo code for my integers, my hash int set. Notice this thing is going to start and do just 10 numbers for now, and it's going to generate a random integer between 1 and maybe 0 and 1,000, and then add it to the list. So we'll set a breakpoint here so that we can look and see what our hash set looks like. So I'm going to run this. Boom, here we go. Here's our debugger and here's our code. It hit the breakpoint. Great. So now let's look at what my ints contains in it. Okay, it is bigger than it was before, right? What was the initial, in fact? The initial, I guess we let it be whatever it was, but it has increased. So somewhere we increased its size. So now let's look at what is in there. So my ints has a size of 10. Notice it's double the size, so actually the length is 14. You can't get to 10 by doubling 7, can you? So 14 is the actual length, and notice here's the references and the rest are null. Now look at this one. I just happened to pick one. 602 is stored there, but look, there's another reference. There's a null, so there was a collision. Even with this large range of numbers, that the random number happened to hit a collision. And now let's look at another one. That one has a null, so that didn't have a collision. No collision. No, yep, that one did. That had a collision, but only 2, right? So our worst case, we still don't have very bad performance if we go and look at all these things. Do we have any with more? I don't think so. Right? So no way to know unless we go and look or print it all out somehow. So that's kind of what we'd expect, right? And of course it would rehash when it got to a bigger size, but hopefully all of that makes perfect sense. There shouldn't be anything mysterious here based on the topics that we discussed, how that code works for integers. So in the next video we're going to pick up and look at a little bit different scenarios, and that is what happens when we're hashing objects, and if we're writing our own objects, how can we support hashing in a nicer way. So that's coming in the next, and I think that'll probably be the last video for this particular topic of hashing. So thanks for watching this one as always.